Okay, this is the setup video for the Newton's Laws lab. Okay, and so if you haven't done so already, now we're going to need to calibrate the sensors. So I'll show you how to do that. And so I'm already turned on and connected here. So I'll go to the little cog wheel and to calibration. And then you can do either one of these first. Maybe I'll just do the force one first. And so the first thing you'll do is you'll leave it set like that on the table. Okay, click the next button, give it a second, it'll calibrate it there. Then you'll want to pick it up by the screw. Okay, hold it by the screw steady. And while you're still holding it, click next. And hold it there steady for a second. And then once it moves on to step 3 of 3, like you see there, you can put it down. And then make sure you hit save. Okay, don't hit close, because if you hit close, then it won't save your calibration. So make sure you click save there. Okay, now we can go back up to the cog wheel, the calibration, and the accelerometer. Okay, and so you just follow these steps here, just like in the picture. And for one of these, we'll actually have to take the eye bolt out. So we'll just unscrew that. Oops. And it's okay if you drop this thing. They're made to be beat up a little bit. Okay, and so you're gonna want to make sure that whatever table you're putting it on, make sure there's no metal nearby. Okay, so like with my table here, the frame is metal, so I'm gonna put it sort of toward the middle of the table where I can feel underneath there's no metal. Okay, because that could mess it up a little bit. All right, and so I'll lay it there like that. I'll click next. And then I just go through all these steps like it shows me. Put it that way, click next. This one's the wheel side up. And then wheel side down. Okay, and now everything's good. So make sure, again, you hit save, not close, okay? All right, and now we should be all ready to go. And so the first part, you're going to use the force sensor. So that's the part we just unscrewed the hook from, so we want to put that back in. Got that tight. And then on the software, we'll just click on the force sensor. We'll hit record, and then if you want to, you can click this re-zero button down here. So especially if you ever see it start, sometimes if something's off, it might start somewhere above or below the 0 line. That will re-zero it if you need to. And then you could just pick it up by the eye hook, and you can see now it's reading force. Okay, it's reading negative force because remember our XYZ axis, right? Y is pointing this way, right? Positive Y is pointing down, negative Y is pointing up. So when we pull on it, we're going to get negative. Okay, if I push on the force sensor, we'll get positive. Okay, now from that, you can go ahead and get the mass of the iLab device. And then in part 2, we're going to look at the force sensor and the accelerometer sensor. So you'll see that accelerometer is darkened out, so that means we have to first hit reset. All right, get rid of everything there, and now it'll show up. Now we can click accelerometer and force. Okay. And with the accelerometer, we're just going to look at the Y direction. So you see all 3 of them are checked off. We'll check off AX and AZ. That way we just see the Y component of the acceleration. Okay, you click record, and then you just want to kind of bob it up and down a bit. And that will help you see the relationship between force and acceleration. And then there's this parametric plot mode, which if you see where my little hand cursor is here, I click that, and we'll see the parametric plot mode. And what I'll do here is I'll bring the cursor down and I'll drag it across, okay, that portion where I was bobbing it up and down. And that will show me, will give me a nice line there, okay? So just like you see in the picture, if the line's going the other way, okay, it means that your force sensor is not calibrated. Okay, that's all it means. Okay, okay, and then with friction, the part on friction, and then we'll go back to the regular mode, get out of parametric plot mode, click on the graph part here. Okay, we can just reset everything so we can just use the force sensor. Okay, and then what you're going to do here is you're going to try to pull the iLab and measure some static friction and kinetic friction. So we're going to put the device, the felt side down, so there's these little felt pieces. Okay, so that'll help give us some friction as we pull. Okay, and you're going to want to do a couple trials here. You're going to want to do actually 4 trials total. So you want to have fine-tuned surfaces to do this on. So I'm just going to use my table as the first surface. Okay, and then 2 different masses. Okay, and so the more mass you put on this, the better this is going to work. Okay, and this can be a little tricky to measure how much something is, but you want to know how much weight or how much mass the object is that you're putting on top. Okay, and so one thing you can do, which I've done before, is I've taken a whole 5-pound bag of flour or something and put it on there, because I know exactly how much that weighs, and I can convert from pounds to kilograms, and I know how much mass I've added to that, and that gives a nice amount of mass. Okay, but if you want to use something else that fits on here, and you know the mass, then that's good. Also, another thing you can do is you can use the eye hook, and if you can find a way to hook it from there, then you can actually get, right? It'll tell you the force on there, and from that you can get the mass of what you're hanging from there. And so what I'm going to do is I'm going to take, since we have 2 iLab devices, I'm going to put one of the iLabs on top of it, and I know now from the first part of the lab how much mass the iLab device has. So now I know my total mass, and then I'm going to give it a pull. Okay, this could be a little tricky, so this is part I really want to show you on here. And so what I'm going to do is I'm going to start recording, and then I'm going to give it a pull. And you see there, I really didn't get the type of graph that I show you in the manual. Okay, it's really tricky to get this. Okay, so don't worry if you're not getting it just perfect. Okay, so it might take several trials to try to get something that sort of resembles it. And the more mass you have on here, the better it's going to work. Okay, so for instance, I'm going to take these other things here. I got this cube in a bucket, put on there. I add some more mass to it, and since I have like a little hook on this bucket, I could hook it to there and get the mass of it. So we'll try to see if I get something better with that. Alright, so a little bit better there, so you can sort of see. I'm going to zoom in just a bit. Okay, so you can see I'm getting that peak there, so that worked pretty well. Okay, and so that peak there, that's going to be your static friction. That's the point where the device overcomes, when I'm pulling, where that was the amount of force required to get the device to start moving. Another thing you could do is take some string, okay, and this might help a little bit too, and just tie it to the eye hook, and then pull. You're going to pull instead of directly on the eye hook. You pull with the string, okay, and sometimes that can help you get that nice little peak there of static friction. Let's see if I get a better peek when I do that. Okay, so not so very good there. We'll try it again here, see. Well, a little bit there. Okay, so it's kind of tricky to do here, okay? But you're gonna try. You can try it several times, see what you get. But even when it's not a very sharp peak, like that first one, when we zoom in, we do really see a little bit of a peak when we zoom in, don't we? Okay, so do your best to try with that. Don't get too discouraged because static friction is not much greater than kinetic friction. But practice this a few times, do your best. Okay, and then you'll do it with a second surface. Okay, so find another surface. I would say find a rougher surface to do it on, maybe like a carpet or maybe a couch or something that's going to have more friction. Okay, then you'll really have a better time getting that nice peak of static friction. Okay, and then finally in the last part, you're going to use the spring. Okay, and this time you're going to use both remotes. Okay, so you're going to want to make sure you calibrate the second device. Okay, and once you do that, you can you're going to want to tie the string, okay, to the eye hook, so it's already tied from the last part, and you're just going to kind of hold it from the string, and you're going to try to measure the tension in the string using that force probe. Okay, and then the final part, you're going to use your finger as a pulley, okay, as pulleys. Okay, so there's going to be some friction, but you remember that in a pulley, in an ideal pulley anyway, that we can neglect friction. So I want you to kind of neglect friction for this here. And so you're going to just try to read, how much friction is in the string based on your readings from the IOLab devices, from the force sensors. Okay, and that's it for the setup for this lab on Newton's laws.